Let's learn about database connections, structured query language, or SQL, in Go. We will discover how to connect to databases using the database or SQL package, explore prepared statements, and learn to handle database operations safely. Now let's explore the database or SQL package. It offers a standard interface for SQL databases with a driver-agnostic design. It features connection pooling built in, along with support for prepared statements and transaction management. Here's a basic example of how to import the database or SQL package, along with the FMT package and the libpq driver. Next, let's establish a database connection. Here's a function called connectDB that returns a pointer to SQL_DB. Inside, the SQL open function is called with the Postgres driver and a connection string. If there is an error, the program will log a fatal error. Finally, the function returns the DB object. Keep these points in mind when you connect. First, SQL open does not establish a connection immediately. The connection is created only when it's needed, which is known as lazy initialization. Always check for errors after attempting to connect. You can use db.ping to verify the connection. Now let's talk about connection validation. Here's a function validateConnection that takes in a pointer to SQL_DB and returns an error. Inside, we call db.ping. If there is an error, we return a formatted error message saying that the connection has failed along with the error message. Otherwise, we print a message to standard output saying database connected successfully. As a best practice, always use db.ping after SQL.open to verify that the database connection is actually working and accessible. Now, let's learn about prepared statements. Here's an example of creating a prepared statement. We call db.prepare and pass in our query. In this case, selecting name from users where ID equals ? If there is an error, log a fatal error. We then defer the statement close function. Finally, we execute the statement with the parameters by calling statement.queryRow and passing in 1, 2, 3. Prepared statements helps prevent SQL injection attacks, provides better performance for repeated queries, automates parameter escaping, and optimizes database query plans. Now let's dive into query operations. This code shows an example of a single row query. First, we declare a variable called name of type string. Then we call db.queryRow, passing in our query and the user ID. Then we call the scan method on the result and pass in the address of name. If there is an error, log the error. The queryRow method returns a single row result. If we want to return multiple rows, we should use the query method. And finally, if we want to insert, update, or delete, we can use the execute method. Next, let's discuss how to handle multiple rows and discuss error handling. The code here shows an example of querying multiple rows. We call db.query, passing in our query. If there's an error, log a fatal error. Then we defer rows.close. Then we iterate through the rows. Inside, we call rows.scan, passing in the address of ID and the address of name. If there is an error, log a fatal error. Always defer rows.close. Check rows.error after iteration. Handle SQL error no rows properly and use context for timeout control. Finally, let's cover transaction management. The code here shows an example of safe database transactions. First, we call db.begin. If there is an error, return the error. Then we defer the transaction rollback function. Next, call trans.execute, passing in our query. If there's an error, return the error. Finally, we return the transaction commit function. To summarize, use prepared statements to prevent SQL injection attacks. Always validate connections with db.ping. Handle errors properly and close resources.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.